Thank you, Gabriella, for that very nice introduction, and thank you all for the very warm welcome today. It's really great to be here this morning, and very glad everybody could make it here. It's a little bit early, 9 o'clock, but I hope everyone has energy. My topic today is the blue ocean of IoT. And in Chinese, when we say blue ocean, we mean the green field, the new opportunities. And so I have two people hiking here. I think they're hiking towards these new opportunities. But I think another key point is no one company, even a company as big as Huawei, can really attack and successfully achieve the IoT industry and dream unless we all work together. So in IoT, it's really a new paradigm of companies working together with the industry, with universities, and with governments. So it's really a much more collaborative environment than we may have had in the past. So I think that's why I wanted to show this picture here. So some of the things I wanted to kind of just introduce is an overview of IoT and where we see the industry going in the next, right now, and maybe the next year, 2 years, even 5 years. So I kind of drew a little tree here of many different opportunities in the IoT area. So we can see some of the things like smart city, transportation, energy and utilities, smart home, many, many things, healthcare, education. So IoT will touch really everything we do in the future. But we think some of the really early commercializable areas will be especially in transportation, energy, smart city, and smart home. So those are some of the areas that I'll kind of go into in more detail. Now, we always hear these numbers of 10 billion devices connected, or 100 billion, or even more. And so really, the number, whether you talk to one analyst or one company or another, these numbers are very interesting and they all get our attention. But the key point is they're huge. And that's why we all want to be in the IoT area. So IoT, we think it's kind of a new thing, but it's really been around in several forms, even from the days of, if you can remember them, of dial-up modems and connecting them with dial-up modems for high-value applications or systems. So in that sense, IoT in what we used to call machine-to-machine format has been around for quite a while. But there's been some changes in the trends. So previously, we'd tend to see things that are very silo-oriented, maybe one solution for one particular application. We'd also tend to see a mess when we tried to connect these different silos together. So it was very difficult to share information between different vertical industries or different applications. So we see this kind of trend moving into the IoT platform, which is one platform that can combine with big data analytics to add new value services that just couldn't have been done previously in the silo area. So another thing we see is in the older connections, we might have dial-up modems or a very low bandwidth type connections. A good example of that would be an electric meter where you have a meter and some back office server. So it's very client server oriented. Very few people, not really rich services. So you may not have video, audio, and people are part of the Internet of Things. So that's really another trend we see is including these rich services. It still includes the low bandwidth, but also high bandwidth as well. And then finally we see a lot of more real-time multimedia type services going on. So some of the kind of constraints for why IoT isn't, we've been talking about IoT for a few years now, and some of the real big constraints and challenges in the industry are, first of all, it's a good challenge to have, but there's just too many opportunities, too many things. And so a lot of our corporate and even educational energies are distributed across too many targets. Another one is there are so many standard bodies, and I'll have a slide that kind of shows an example of that, but there's so many standardizations that it's very difficult to bring everybody together. I think in the telecom, for telephone, 3GPP has done a very good job of globally industrializing that industry. But we really don't have that yet in IoT, or we have it in too many places. So this is just an example of all the organizations that are involved in smart home. And it's really a mess. You could spend all of your time just following what these organizations are doing and never really achieving anything that's practical. And so for Huawei, we're very, very involved, and as are some other large companies like Huawei, in working with different standards bodies to try to bring order out of this chaos. So this is really a big area of effort for us. So we stand as board of director members in most of these organizations. So I say industry standardization is very important, but it tends to be slower. So another area we're working very hard, and with other big companies, is in the industry alliance area. So this actually can allow large companies to get together, cooperate, and move faster than the traditional standardization. But they're both very important. Okay, so that's kind of maybe a little bit of background of IoT and where we see things are happening. But now I'd kind of like to just talk a little bit about the enabling technologies. What do we need as a basis to start achieving IoT? So I'll kind of focus on platform, So narrowband connectivity, we call it NB-IoT. Also light OS, and then gateways and fixed network. So every part of the network has its part to play. So in Huawei, we kind of have an architecture that, in Chinese, we always like numerical slogans. So we call it 1 + 2 + 1. So we talk about having 2 access networks that can connect into one IoT platform. And then we have one light OS that we're open sourcing to the industry. So these are our big areas of investment as Huawei. So we're investing very heavily in light OS, developing that open source. And the reason for that is, as a connectivity company, we want more terminals to connect. So if we can help the industry that way, it helps ourselves as well. The next thing, the wireless and fixed, we need both types of connectivities in IoT. Both are very important. And I'll go through some different applications of those. And then the IoT platform is very important because that's bringing all the data together and allowing us to share information with big data analytics. So kind of if we take a look at the way a typical carrier would view IoT in the past, and even many view it this way right now, they kind of think in terms of selling SIM cards. So if they can sell SIM cards to a point-of-sale device, or they can sell SIM cards for fleet management for automobiles, that's kind of their view of IoT. Now, what we're working very hard with others in the industry is to expand that idea that we're going to go from selling SIM cards and machine-to-machine type application to a little bit bigger world where we have different types of applications. We can have smart home or connected buildings or citywide management going through fixed network and gateways. We could have home gateways for smart home. We could have still the current 2G, 3G, LTE, and SIM cards for fleet management. That's probably a killer app in that space. And then finally, we have a new technology called Narrowband IoT that we're pushing out to all the carriers. And I'll go into some more detail on that. But that's been standardized just this summer through 3GPP. So that'll be we think, a very quick uptake. And so what that will do is enable a lot of anything that has meter in its name or sensor in its name typically would fall into that category. And then the key point, we'll use these technologies, access technologies, to come into one IoT platform. Then we'll provide standardized APIs that can support different developers to go make applications on top of all this network. So that's the key secret sauce, is we want to enable people to deploy their applications on the network. So some of the kind of key points for an IoT platform, of course our IoT platform follows these points, but we think this is general in the industry, that this is what will be needed to achieve these things, is we'll have one layer that's responsible for connectivity management. That would include SIM card, and even more important going forward, non-SIM card. So again, most telecom carriers think in terms of how do I sell SIM cards, but really the reality is most IoT devices won't have SIM cards in them. And so being able to do non-SIM card management is also a very important part. An example would be smart home. All the sensors in a smart home really won't be SIM card devices. Okay, so this would be the connectivity layer. And then at the application layer, there's also some key very important parts. One is having open and standardized APIs so that application developers can easily work with your platform. Another one would be service orchestration, or also you can hear it called IFFT, which is if this, then that type of logic. So you can make on the fly, very fast time to market new services with basic logic. And it's usually using drag and drop, so it's very, very easy for end users. And then another important one to talk about is big data. So having all this information from people and also from sensors coming into one platform is really providing a lot of value. So we'll kind of go into that just briefly as well. So I think for things to consider in future-proofing your IoT platform and being able to do what's needed now and also for the next 5 years, these would be some of the key areas. We should look for cloud native and running on COTS servers. So that needs to be very extensible. We need quick time to market. We need to support both the SIM and non-SIM. And then access agnostic, so it needs to support all the different access networks. So I just mentioned big data a minute ago. So this is kind of how we see big data working with the IoT platform. So the platform itself would be here. And really, together, they're one IoT platform. But the non-big data part, basically the data collection part, would be here. And there would be interfaces into the data analytics section. This is where the big storage of all the data would happen. Now, we also have some type of applications that I always view it in terms of the human brain. So we have some motions, like reflex, that happen almost real time, and they don't require a whole lot of processing and thought. So a good example of that would be my home door opens and alarm happens. So that would be kind of following this path and more the reflexive mode. So there's not a lot of need for big data analytics in that type of application. So smart home would tend to be more here. On the other hand, if we have large building efficiency management, now I need to look at what happened last month, maybe compare year by year, compare how many people are in the building versus how much energy is consumed. I need to be able to figure out a lot of different ways to look at the data. So at that point, this would be a better way to process that type of IoT data. So that's kind of the overall relationship between big data and IoT. And then security. And I'm just touching on each one of these quite briefly, so definitely look forward to questions or comments later in the presentation. But security is another very, very key point. And so it's not enough to just have security at the device or have security at the platform. It really needs to be considered end-to-end. And so this is kind of some of the things we look at. So for Zigbee or Z-Wave type connectivity into smart home, that's using AES 128. So that's typically the standard that we would use end-to-end. And some of the other things to think about, certain industries are much more stringent than others. So for example, electric utility industry has to follow the NIST, the National Institute of Science and Technology in North America. That's kind of the de facto standard for most utility companies. Very, very strict. For smart home, it's a little bit more lax, but still it's following AES 128 end-to-end. Another kind of concept in IoT platform, and again, for Huawei, we're very focused on working with large utilities, large enterprises, and also, of course, carriers. So for a carrier, they already have a lot of interesting capability. They have the capability to provide a certain amount of bandwidth for a certain type of service to a certain particular user. So they call that the policy control and rules function as part of their core network. They also have IMS, so they can do things like video call forwarding from one device to one user to a second user if need be. So by being able to integrate into those interfaces, we believe an IoT platform can be much more readily ingested by the telecom world and also have a lot more power to take advantage of their existing network. So those are some of the kind of key considerations we would think for IoT platform there. Now, so that's kind of the background of IoT platform. Another area in our 1+2+1 would be the OS. And so this, again, for Huawei, we definitely support any type of device with any type of OS. But we feel that the operating system is kind of a hindrance to the adoption of IoT. And so we're really investing quite a bit in open sourcing what we call Light OS. Now, Light OS is running on Linux. It's a Linux kernel, but it's been optimized to have a very, very small footprint. So it can operate in 20K kilobits, but I think our latest version now is down to 10 kilobytes. So it's extremely, extremely small for the core kernel of the OS. Now, there can be additional add-ons for other types of services, like, for instance, Wi-Fi, Ethernet, RF. We have different plugins, but the very core of it is only about 10 kbytes. So the goal of that and the reason for that is to bring the cost of the terminals down. So if I have a $20 water meter, but because I have to add additional memory, et cetera, all of a sudden it's a $50 water meter, there's no business case for it. So bringing the cost down on the terminals is a very, very key part of IoT. Another kind of good optimization is there's really two things that consume battery, and battery for a non-power device, very important. So one is the radio. So the best way to optimize that will go into NB-IoT, but the best way to optimize that, keep the radio off almost all the time. For the other thing, the operating system is always running in the background, so by having an optimized operating system, this is another reduction of battery consumption. So this is very, very key for enabling the IoT technology, and especially in the terminal space. Okay, so kind of moving on to another, and we'll kind of just go through a few topics of IoT, but another topic would be connectivity. So if we talk about IoT, it really includes connecting everything. So everything could be anything from a water meter that only sends 100 kilobytes per day, or 100 bytes per day, to some remote surgery where a doctor is operating in the surgery and a machine is performing his motions far away. So these are very drastically different requirements. And so in the industry we have, in the future, we're focusing on 5G technology, which will allow these types of very cool technology like remote driverless car, remote surgery, things like that. Also replacing in electric utility control of things like SCADA, for example. So that would be 5G, and we're targeting that for about 2020. But we're also already doing R&D and a lot of activity in concept trials, but commercially we're thinking about 2020. Now, on the other hand, we have a lot of devices that can be connected right now today with 2G, 3G, and LTE. So that's there for us now. And then finally, we have a new technology that's just been standardized this summer by 3GPP, and it's in their release 13. It's called Narrowband IoT. And we'll go into that, but the narrowband just means it's using a very narrow slice of the existing spectrum that's used for LTE or GSM. And now, all of a sudden, we can repurpose that narrow slice of spectrum for machines. Because machines, especially these type of low power and very low data rate machines, they don't care about delay, and they don't care about bandwidth. So my voice right now is about, roughly speaking, 8 kilobits per second in bandwidth. For a machine, like a water meter, only uses 100 bytes per day. So you can see there's a very drastic difference between human needs and machine needs in this case. So another part of low power wide area or narrowband IoT is connectivity. So we have a lot of devices that are in places where people aren't. And as an IoT person, I can just walk down the street and I see so many opportunities. There's water meters and streetlights, everything. So these would be examples of devices that are in either very wide coverage areas or very difficult to reach. Usually they're battery operated. So this is a whole new class of devices that we're trying to build business case for. So with NB-IoT or narrowband IoT, what we can do is we can increase the coverage of a standard cell site by 20 dB. And if you're not an RF person, 20 dB is about the difference between talking like this and talking like this. So that's probably a good analysis of what 20 dB can achieve. So all of a sudden, we can penetrate through more walls, we can penetrate through ground cover or snow or leaves, things like that. And so we can connect many, many more devices. Now, once you have this good coverage, you have to be able to connect more devices per base station. And so by relaxing the constraints of delay, we can connect up to 100,000 devices per base station, where typical human use, about 1,000 devices per base station. Now, that's on the technology side. On the cost side, we need to have low power consumption. So if I have to go replace the battery every 2 weeks, the OpEx would kill me. So we have typically designed the battery life to be the equal of the device life. So if it's a water meter, it's typically a 10-year life cycle. So they replace every 10 years, so the battery has to last 10 years. For low cost on the module, I have a slide about that. But if a water meter costs $25 and I'm telling the water company, oh, I'll sell you a $25 communication module, the immediate answer will be no. So cost is very important. We'll have a slide about that. And then being able to reuse the existing cellular network investment. So it's almost a zero, I won't say zero cost, but it's a very low cost upgrade to make this new business case available to the existing cellular network. So that's my 20 dB right there. Okay, so one other key point is being able to reuse the spectrum like I was mentioning earlier. So the cell phone companies and telecom companies have invested billions of dollars in their spectrum. So reusing that spectrum very efficiently is important to them. And so what we can do is take just a narrow slice of spectrum. It can either be in standalone, it can also be in GPRS frequency, or in LTE guard band, or also LTE in-band, depending on the deployment requirement. So if I'm a carrier and I have 2 LTE channels that are adjacent, there's an in-between guard band, that's really unused. And so we can reuse that, and this is basically money for zero cost, which is a great thing. Now, this is on the spectrum side. On the hardware side, we can do a software-only upgrade to the existing baseband unit of their base stations. So now we're reusing the antenna, the cell site, the tower, everything. So very low cost to upgrade that site. And then in the core network, we're using NFV architecture. And that's a whole other area of topic, very interesting. But the idea is it becomes very, very scalable to handle increasing demands. And then we can use the same operational system investment and billing system investment that the operators made. So it's very, very easy overlay. So this is kind of my slide about cost. Now for low power wide area, this has been around for maybe about, I'll say, 6 years or so. It's kind of a relatively new technology, but there are several players in this area. So we have traditional LTE, we have Cat0, Cat-M, these are other standardized versions. They have higher bandwidth and, as you can see, higher costs. We think it's not quite as applicable to most metering type applications. Then we've got other purpose-designed low power wide area companies out there. Sigfox would be an example. LoRa also would be an example. And so you can see that they're bringing the cost of the chipset and modules down, but we feel that NB-IoT will be the lowest cost solution. And another good thing is this is being globally industrialized through 3GPP. So all the big players, Qualcomm, Sequans, Huawei, Intel, will be developing chipsets for NB-IoT. So we think that's a real key to get the economy of scale. There we go. Okay, so once we have this narrowband IoT technology deployed, and we've actually been working on proof of concepts with some of our large carrier customers for the last 2 years. So we're very, very confident in this deployment. And the standardization process, like I mentioned earlier, it takes a lot of time. So during this time, we've been doing pre-standardization, proof of concept, and really ringing the bell on this. So these are some of the different types of applications that we've deployed with some of our various carrier partners as proof of concept of this narrowband IoT. So we feel that it's very ready to be industrialized, and we'll start our first commercial deployments in January of next year, 2017. So this is an example of fixed network. So we can't forget about fixed network. There will probably be not so many devices connected to fixed network directly, but by going through IoT gateways, that's where most of those devices will be connected through Zigbee or Z-Wave or some other Wi-Fi, usually a wireless technology, but going into a gateway that's then connected into the fixed network. And so this is very appropriate for high bandwidth applications. So in terms of smart home, we may have some devices that are connecting in with Zigbee, and we'll have some device that may be an IP camera that requires higher bandwidth. So this would be utilizing the fixed network as part of IoT overall backbone. So those, I think, are kind of some of the enabling technologies that are coming together right now, or I should say have come together, and now we're able to start working on applications in IoT. So probably this first one that everybody has probably seen or heard of, and we're working here locally in Costa Rica, and we have a demo center for smart home. And the idea here is that we would use the same IoT platform I was talking about earlier to connect in via the fixed network to home gateways, and then these would connect in via wireless Wi-Fi or Zigbee to different sensor devices and IP cameras. And then by doing that, we can have logic here in the platform that can, this then that type of logic that can allow us, if a door is open, we flash the lights or things like that. If there's a smoke alarm, we automatically make a dial call to the police department or the fire department. So any type of logic really can be added. So it's almost anything you want to do in smart home could be achieved that way with sensors and logic, and then the capability of the network that we talked about earlier. That's where it's so important for the IoT platform to be linked into the existing core network of the carrier. And then, of course, you have to have the applications running on the handset that can control the home. So here's an example we're deploying with Telefonica, just based on that architecture I explained previously. So they kind of have a two-step strategy, which I think is the right thing, and focus on simple applications first. We could say the killer applications will always be home safety and home security, and then from that move into other things like home automation, home optimization of electric and temperature, things like that. So in this type of application, I think maybe there have been some other speeches earlier, but in ICT, cloudification is extremely important. So this is a cloud-based IoT platform that we're actually hosting in Mexico City, and then we're providing service in these 3 countries here in Latin America. So it's very, very cloud-based. Now, I mentioned earlier that we can't do this all alone, and so these are just some examples of our partners in the smart home space. So I'll go through some other partners in other spaces, but I think the key message here is it really takes a large ecosystem to work together to be able to deploy these types of applications on a global basis. And so even for these smart home sensors, go back one here, even for these type of smart home sensors, we have very strong partners in Europe, in Asia, and also in the United States. So we have many, many choices for devices. For the same single functional device, we could have 6 or 7 different choices depending on what the carrier requires. Okay, so the next kind of topic, and again, I'm going through these kind of fast, but hope you'll maybe jot down some questions and notes we can discuss afterwards. But smart city is a huge area of interest. And so smart city, I think to start out the discussion, what is smart city? It might be one thing for this group of the people on this side, it might be another thing for this group here. So defining what smart city is a very important part. So if we go to Singapore, they'll have their definition of what smart city is. Dubai will have a very different definition. So in Dubai, water management, extremely important. It's a desert. In Singapore, they don't care about it so much. So it really depends on the city. But I think I just want to mention that when we say smart city, it's not a cookie cutter thing. Okay, so remember our 1 plus 2 plus 1. Well, that comes back in our overall smart city architecture. So if we look at it from a very high level, we would have our IoT devices that could be deployed out on streetlights or underground or all over the city. We'd have, of course, our access networks, both fixed and wireless. And then we'd have our platform, and that can include the core network platform like IMS, for example, that would be very important for safe city video routing, and also our IoT platform. There we go. And then on top, we'd have all of our applications. So I'm not going to read each one of these, but many, many different applications. And I don't have time to go through each one, but definitely if there's questions in the question and answer session or later, I'd be very glad to discuss some of these deployments we're doing. But these are just examples of smart city applications. And then there'd typically be an integrated operations center to tie it all together at the city level. So again, my story about partners, we can't do it alone, and so we really have a whole other group of partners that are involved in smart city effort. And there may be some overlap between smart home and smart city, but these tend to be more industrialized partners. These are just some solutions. I had too many slides, so I'll only go through the ones with gold here. But this would be an example of smart water metering. Again, so smart water metering, the water meters are located where it's very, very difficult to reach. So NB-IoT would be the technology of choice to reach those meters. They're also battery operated, so again, the 10-year lifespan, very important. And they're typically very cheap devices, so the $5 cost, very important. So really, this is almost a poster child application for NB-IoT. Now, the idea here is if we try to use GPRS, it can't reach. So Zigbee, we could reach it with the short-range solution, but the cost is too high by the time you deploy all these extra data collector units and gateways. And so NB-IoT is really the choice. And here we're working with these two partners. We're doing deployments in Australia. Australia will be our first standardized commercial deployment. And we've done several proof of concepts in Spain and in Dubai as well. So this is something we feel we're very ready to industrialize right now. Another good one is street lighting. Now, for city government, water meters aren't so visible to the population, but if they start making smart streetlights, this is something very visible. So sometimes this is also a very good application, very popular application in smart city. So the idea here is you can use fixed network to come into these streetlight locations, have a fixed gateway here that's using Zigbee or 6LoWPAN to connect the different streetlights, and all of a sudden you can add additional services. You can add things like digital signage, you can add IP cameras for safety and security. You can add Wi-Fi hotspots for citywide Wi-Fi. So it's really a very valuable location in the smart city. So streetlights are very good real estate for IoT. And I'm going through these kind of fast, but safe city is another very important application. So it's important in prevention of crime, control of the streets, and optimization of the streets, management, and also for later on follow-on investigations. So this would be an example of the overall smart city control room. And again, we're taking all this data from the different sensors, IP cameras, bringing it into the IoT platform, having access to big data analytics, and so we can do a lot of very interesting city services through this. My next topic is power grid applications. And I think this is a very interesting one because it's such a huge area and it's such a huge need socially. So if we can avoid developing and manufacturing one additional power plant, they're very costly, they're very damaging to the environment. So if we can avoid by modifying the peak usage, this is really, really a great social benefit as well as commercial benefit. So when we talk about power IoT, it's very, very similar to some of the things we talked about before. Let's just go in electric utility, there's generation, there's transmission, distribution, and then metering. These are kind of the three big parts of electric utility. Of course, utilities are huge companies. They have thousands of air conditioners, thousands of sites. There's a lot of copper theft in the sites, so security location is very important for them. Also, they have vehicles, so fleet management can be a very good optimization. So there's really very, very many IoT needs in an electric utility industry space. But we'll go through some of the big ones. So this is an example of generation. This is a plant in Qinghai, China, which is western China, very sunny area. And so here, they're generating 130 milliwatts, and this is using Huawei's inverter strings, and also using our IoT technology to do remote monitoring. So we can do things like generate higher yield from this plant. So if we didn't have IoT, the yield would be about 3% lower. Now 3% doesn't sound like very much, but it really adds up when you're talking about 130 megawatts of production. Also, we can increase the OFDM, the management efficiency. If we can immediately locate the fault, we send a guy out to fix this panel instead of having to roam around hundreds of panels or thousands of panels to find where the fault is. So this reduces the operational costs. So if we take a look at the overall result, we can increase the internal rate of return on this project by about 2.75%. So the economists in the room can tell us that's a very, very important and good thing. Here's another example if we kind of move down the food chain. So we have generation, and then the next step would be transmission and distribution. So for distribution networks, the problem is we're sending electricity through all these wires, and we want to optimize that. And also, of course, if there's a problem, we want to be able to identify that very rapidly. So the idea here is we deployed 50 RTUs. That stands for remote terminal unit. It's a sensor. And about 500 smart meters and 40 IP cameras. And so the results of that, this is all based on what we call ELTE, or enterprise LTE. So the enterprise LTE is the same as LTE that we use for our phone, but it's repurposed to ISM band. So it's a spectrum that can be deployed by the utility without a license. So that's very good for utilities. So the result of that is by having these RTUs on the transmission lines and distribution lines, we're able to do very, very fast fault location. So normally it would take them about 30 minutes to send a crew out and track down where the fault is. We can now do it automatically in 1 minute. So that's a huge savings. You can imagine if there's a factory that has a process, maybe they have a 5-minute power generation emergency capability, this 30 minutes can make a big difference. So there's also a huge financial impact on insurance costs to the utilities when they have these outages. So just the insurance savings alone usually pays for these types of projects. Now, another one is the RTU rate. When they were using older technology, sometimes the coverage was there, sometimes not. With ELTE, it's 100% online all the time. And also, there's much faster bandwidth and much faster delay. So it's about 10 milliseconds of delay in this network. It can be optimized for lower delay. So this allows for some closed-loop type applications that typically wouldn't be available using GPRS or GSM. So that's another kind of good benefit. And then finally, the power supply reliability to the city increased to 99%, which was their goal. Okay, so if we move down the food chain one more step, now we're at metering. So metering, or advanced metering infrastructure, AMI as it's called in utility industry, is about connecting smart meters to the network. And this is a use case in Nigeria where we deployed about 300 million meters, 300,000 meters. And here, the problem was there was a lot of theft. They didn't know what was going on. They had people collect manually the billing, but they were getting very low collection rate. And so by deploying AMI, connecting these meters in, and then having gateways and then connecting into a back office IoT platform, they were able to reduce the loss from about 45% to 14%. Now, in the electric utility industry, they have a term called non-technical loss. So non-technical loss to you and me means stealing. So this was non-technical loss here. So they were able to eliminate theft from their network pretty much. Also, the cash cycle, even the money they could collect, it took them about 3 months to actually get the money from the time it was metered or measured to the time when the end user paid. So here, they're able to collect it within 45 days. That's with the post-pay. They also have a prepay system where they can collect the money real time. So it's been very, very good for them economically. So their payment success has gone from about 60% to 100% with this AMI technology. And here they're increasing their metering customers by 23% each year. So they're basically taking these profits and rolling it back into AMI to improve their network. So this is kind of maybe a block diagram of how that would work. So we'd have our meters connecting into what we call a DCU, or a data collection unit, and that's just another word for a gateway. And so this is going to take typically PLC, power line communication data from these meters, combine it together in this data collector unit, and then send it up over GPRS, and then there would be the IoT platform in the background here. And so by doing that, again, they had all these great benefits here. Okay, so the next thing I want to kind of mention real quickly is challenges for narrowband. So when we connect these devices, typically power utilities, they own the power lines. So the communication technology they love is called power line communication. It's just sending the signal over the power lines and then collecting it and sending it up to the back office. That's great, but it has some problems. So some of the problems are it's very low bandwidth and there's a lot of noise and it's very difficult to get the information across. So it's not really received 100% of the time. Another problem is it's very low bandwidth, so if you want to do an upgrade to the firmware in the meters, it's very, very difficult to do this upgrade. It really has to be done manually. So now you're all of a sudden back to manual operation, which is very costly. So to solve that problem, the industry is moving away from this type of narrowband PLC communication to what's called wideband or broadband PLC. Now, broadband PLC started out with G3 PLC, and it, as you can see, had 36 carriers, which is a good thing. But we see a trend in the industry now. There's Prime Alliance going to 97. And now, with Huawei, we've been deploying about 1 million meters in China with this technology. We call it high PLC, but it's broadband PLC that has 512 carriers. So by adding these additional carriers, you have much more bandwidth to the meters, and also a lot more flexibility in handling noise and those types of problems on the electrical line. So I'll kind of go through that just real quickly. It's using OFDM technology, so I think I have time. So it's using OFDM technology, and the idea is that we'll use different tones to send information. This is the same technology we're using in LTE, and in most modern cutting-edge communications will use OFDM. And so the idea here is that by using OFDM, we overlap these tones. Now, in time domain, it seems like it's overlapping and it would be noise. But in frequency domain, we can see that I hope we can see that the zeros of each of these would offset each other. So that the positive point of the signal in frequency domain corresponds to the 0 point of all the other tones. So that's why it's orthogonal in nature. I think the next picture I have will show that better. But the concept is by using this OFDM technology, we can save about 50% bandwidth. So it's much, much more spectrally efficient. And there we go. And so we can see that this would be in time domain, but in frequency domain, they're not really overlapping like they appear to in time domain. So here we can see the peak of this would correspond to the zeros of all the others. So in frequency domain, they really are orthogonal to each other. And so that allows us to send information on each one of these tones. And in the case of sending over power line, unfortunately, power lines weren't meant to send signals. So there are some problems there. One of the problems is that we'll see certain frequencies where there's a very large drop in this blue line kind of would represent the transfer function of that power line. And so if the power line is having certain frequencies that have very bad performance, we can just avoid those frequencies or block them out. And so by having the 512 carriers, we can have enough bandwidth to choose which ones we send. Now this is all time varying, so it's not as simple as what I'm showing here, but on a time basis, different frequencies will have different amounts of channel loss, and so we can dynamically adjust to that. And by having the 512 channels, we can effectively avoid that. So another problem with power line communication is noise. So whenever a refrigerator turns on or whenever a switching power supply turns on, that puts noise on the power line. And that noise can also be detected and avoided in the same manner. So by using this kind of technology, we're able to have a very high bandwidth connection between the electric meter and the data collector going over the existing power lines. And that's really what utility companies are very, very interested in. So this is just kind of comparing the different types of PLC. So we have narrowband here, G3 as an example here, and then broadband PLC here. And so you can see probably some of the high points are here in red, but much higher bandwidth to the application layer on the meter. We have things like we can do a single reading time in less than a second here, where it takes several seconds here, and much longer here for traditional. And we can do things like have self-network. So in case the data collector is lost or damaged, the network can redefine itself. And so by being able to do that within about 5 minutes, we don't lose any electric utility information. Typically, utility companies will collect data on every 15-minute clock stroke. So they're collecting information for their whole network every 15 minutes. That would be an advanced utility. So being able to re-network within 5 minutes allows that to be seamless to them. And then another key thing is we have the ability to do remote upgrade. Very, very key point. So if we take a look at some of the challenges for electric utility, again, this huge space. So some of the smaller utilities, they're very happy to work with carriers and do what we call metering as a service. So they'll use the narrowband IoT or existing GPRS to do wireless connectivity to electric meters. But For larger utilities, typically the operational cost will be so high to connect millions and millions of meters that they'll tend to want to do their own internal network. So these are some of the considerations. So for the public network for utilities, it may not have the signal coverage that they need. It may not have the data security level that they want. And then it's going to have the high OpEx cost. So this would be kind of an architecture of how this would work together. So we'd have the one-air ELTE, which is LTE operating in unlicensed spectrum, or one-air IoT, which is NB-IoT, again, operating in unlicensed spectrum. So just repurposed for utility enterprise. But the idea here is this would provide AMI connectivity and sensor monitoring for low bandwidth applications, and this would supply the distribution automation for high bandwidth type applications. And I think an example where we've done this deployment is in Mexico. And here we've deployed basically the backbone network for wireless ELTE. And we allowed them to reduce their line loss with AMI, which is a key point. And also, they were able to reduce their operating costs by about 50%. So it's a huge operating cost. Probably the biggest operating cost for an AMI network would be leasing network resource. So again, to kind of go back to my key thing that in the electric power utility and power IoT industry, again, Huawei's very active here, but we really rely on our partners. Very, very key to have partners. And I think I'll wrap it up by saying communications, platform, and ecosystem. I think these are the three, if you remember anything from this discussion today, these would be the three things to remember. And on the technology side, I think NB-IoT is a very, very interesting thing. It has its enterprise flavor, which is one-air LTE and one-air IoT. And platform, we talked about some of the key points: security, flexibility, multi-protocol support, and openness, the APIs, partners, and ecosystem. So with that, I'd really like to thank everybody. And I think in IoT, one of the big challenges is to take all these opportunities and make it so that we can attack those opportunities. So thank you very much. And definitely